Chapter 1: The End of Birdbrained, presented by the BirdLens app. Welcome to BirdLens.
This is Episode 2 and Part 1, Chapter 1, the Chapter Introduction. This is Episode 2, the Chapter 1 Introduction in Part 1, Rethinking the Bird Brain. The previous episode introduced the part. Today, we open its first chapter.
Before we begin, you need only a basic idea of intelligence. Intelligence means solving problems, learning, remembering, or adapting. No neuroscience background is required.
First, we will define birdbrained, neuron, pallium, and cognition. Then we will trace old assumptions and their scientific reversal. Finally, we will test that reversal with birds, brains, and behavior.
First, we will define the foundation. Then, we will trace the history and examine deeper evidence. Here is today's quiz. What does the insult birdbrained reveal about how science once judged intelligence?
In my opinion, we should slow down and parse the wording carefully. I will defer the answer until Sheila reveals it near the end.
Compared with the prior episode, today we increase technical complexity. Let's begin with terms. Birdbrained means foolish, especially because of an assumed small or simple brain.
A neuron is a nerve cell that sends and processes signals. The pallium is a major bird forebrain region. Cognition means processes such as learning, remembering, and deciding.
My prerequisite is simple. A small skull does not automatically mean a simple mind. Victor, is the pallium like a bird version of the mammalian cortex?
That comparison is useful, Sheila, with one correction. Bird pallium is organized in clusters, not mammalian layers. Still, it performs some functions similar to mammalian cortex.
Now, the history. Why did scientists connect birds with instinct and mental simplicity?
Older terminology treated much of the avian cerebrum as related to instinctive behavior. Researchers also assumed flexible intelligence required a mammalian neocortex.
The motivation was understandable. Scientists used familiar mammals as their measuring stick. How did that interpretation evolve?
The Avian Brain Nomenclature Consortium challenged the century-old view. It argued that birds have a large pallial territory with functions similar to mammalian cortex.
So the origin was mammal-centered anatomy. The motivation was classification. The evolution came through better comparative neuroscience.
Exactly. A revised brain map changed the question. Researchers could ask how bird structures solve problems rather than whether birds possess the mammal design.
I think I understand. Scientists mistook unfamiliar organization for absent ability. Victor, please correct me.
Your understanding is strong, Sheila. Add one distinction. Related functions can arise from different architectures. Similar performance does not require identical anatomy.
My analogy is a compact city beside a sprawling city. Their roads differ, but signals, routes, and decisions can coordinate traffic in both.
That maps well. The compact city represents clustered bird pallium. The sprawling city represents layered mammalian cortex. Different layouts can support overlapping work.
Are we assuming that more neurons always means more intelligence? The bird might also fit its environment unusually well.
That assumption needs refinement. Neuron number helps explain processing capacity. Intelligence also depends on wiring, learning, motivation, and ecological demands. Sheila, which factor would you observe first?
I would start with repeated behavior. Here is an edge case. A bird solves a laboratory puzzle once, then fails during unfamiliar weather. Does that prove inflexible intelligence?
No. Stress, motivation, or an unnatural task could explain the failure. Strong conclusions require repeated behavior across suitable settings, not one dramatic performance.
For a real-world action, I would observe a backyard bird across several visits. I would record conditions, repeated choices, and whether its behavior adapts.
That is a sound implementation. Compare consistent flexibility with one lucky movement. Keep observation separate from interpretation.
Here is my comparison. Brain size is building floor area. Neuron density is the number of active workers inside. Which comparison helps more?
Both help, but density explains a major surprise. Research found that parrots and songbirds average about twice as many neurons as primate brains of equal mass.
A concrete pitfall is calling small bird brains miniature human brains. I would avoid that by asking what each bird does in its own ecological setting.
Exactly. My best practice tip is to describe behavior first, then propose a mental process. That order reduces anthropomorphic overreach.
A distinct fact is that some corvids and parrots have forebrain neuron counts comparable to primates with much larger brains.
A distinct anecdote concerns Betty, a New Caledonian crow. She bent straight garden wire into a hook and lifted a baited bucket from a well.
Later field research added important context. Wild-caught crows produced 85 hooked stick tools. 10 subjects deliberately bent tools during some or all manufacturing episodes.
That evidence matters because Betty was not simply a laboratory miracle. Tool bending belongs to the species' natural behavioral repertoire.
My mnemonic is MAP: meaningful behavior, architecture, and performance across settings. It reminds me not to judge one clue alone.
Good mnemonic, Sheila. To summarize this iteration, unfamiliar anatomy does not equal primitive cognition. Bird pallium can support flexible functions without copying mammalian layers.
Tools are not the whole story. Scrub jays remembered what food they cached, where they placed it, and when they placed it.
Pigeons learned to distinguish Monet from Picasso paintings. They also generalized that distinction to novel paintings. Pigeons learned to distinguish Monet from Picasso paintings. They also generalized that distinction to novel paintings.
Alex, a gray parrot, demonstrated numerical comprehension. He used none to designate an absence of quantity.
Together, these cases broaden the picture. Avian cognition includes memory, categorization, numerical concepts, and tool behavior across different lineages.
Let me answer the quiz. Birdbrained reveals an old assumption that intelligence requires mammal-like brains and human-familiar behavior.
That is the answer, and your reasoning is accurate. The insult preserved a scientific mistake, confusing different design with lesser ability.
Here is the recap. Birdbrained was an obsolete judgment. The pallium supports flexible cognition. Neuron density complicates brain size comparisons. Different birds show different abilities.
Next in the series is Episode 3, Part 1, Chapter 1, Section 1, Why Scientists Underestimated Birds for So Long. It examines that underestimation directly.
Subscribe to and rate Birdlens. Download the Birdlens app. Thanks for learning with us, Victor.
Thank you, Sheila. And thanks for listening. Keep questioning labels that make unfamiliar minds seem small.